All right. So today we are going to be taking notes on the atomic structure. So this is, or sorry, on the ions page. So I believe it's page 12 in your notes here. So, yep. So concept 3 here is about the formation of ions and what is an ion and the different types of ions that we have. So we'll talk about those. Let's present here. Okay. So our goals for today are to describe how anions and cations are formed, the difference between those words, and then give the different charges for an ion based on the number of protons and electrons. So to practice with using those, and then show the appropriate abbreviations for ions using some boxes and some setups there. Oops, sorry. Okay, so first of all, what is an ion? And this was one question I believe was in like one of your bell works, one of your first bell works. And I told you guys at the time, you guys might not know this, so maybe you needed to look it up. But an ion is an atom. What we're going to start out with is just talking about atoms. But as we move forward, we're actually going to learn about groups of atoms, basically like a molecule, that have positive or negative charges. So either for now we're just going to worry about single atoms that have a positive or negative charge, but actually a whole group of atoms can have a positive or a negative charge. So we call those polyatomic ions, the word poly meaning many and atomic meaning atoms. So like H2O, it wouldn't be one because that's just water. But like H2O would have a negative or a positive charge to it. Like I said, H2O isn't one, but that's just an example of a group of atoms. And ions form when an atom either gains or loses electrons. So remember, we have isotopes, which a lot of students initially will confuse isotopes and ions because obviously they both start with I. Isotopes either kind of gain or lose neutrons, and that's how they get to become different from each other. But you still have the same element. Ions are similar, except now you're dealing with the losing or gaining of electrons. Now, electrons, remember, carry a negative charge. So with isotopes, when you lose or gain neutrons, it doesn't affect your charge, but it does affect your mass, right? Because the neutrons are in the center of the nucleus, and they will affect your mass by by a factor of 1. But with electrons, they don't affect your mass, but they do affect your charges. So that's what we focus on with ions, is how has our charges changed now that we have lost or gained electrons. And electrons are really, really important for bonding and things like that when we get moving forward here. So we'll see lots of ions in the future. So how to write ions. Ionic charge is written as a sign, so either a positive with a positive sign or a negative followed by a number. And then usually it's what we call superscripted, meaning it's up and above the element or the atom. And then the number that's behind it represents the amount of electrons gained or lost. So you'll have either a plus sign or a negative sign. And then a lot of times there is positives or either a number behind there. If there's not a number, we can assume that it's 1. All right, so just kind of like exponents, you can assume that it's a 1 if it's not, if you don't see anything there. All right, so again, the number represents the number of electrons gained or lost. And it's a little bit tricky or backwards in our thinking. Usually when we see something that says +2 or +3, we think, oh, it's gained 2. It's gained 3. But we're going to see here that that's not the case for electrons. So we have two types of ions based on their charge. We have positive ions known as cations. So cations are an atom, or again a group of atoms that have a positive charge. So anything that has a positive charge, doesn't matter if it's +1, +2, +7, it'll be a cation. And where we see cations on the periodic table are usually in our metals, especially in our groups 1 and 2, which are the first two columns of the periodic table, and then those transition metals, which are in the middle of the periodic table. So that's where you're going to see a lot of your positive charges on the periodic table. So most of those that I talked about on the periodic table are forms of metals. So metals tend to lose electrons and become cations. Now, I just said they lose electrons, but then I said they are positive. All right, and that is because of this the idea of the charges. If you lose electrons have a negative charge, don't they? So if you lose electrons, you become more positive. Like your proton number never changes, because otherwise you change your element. But your electron number, if that changes, now you're no longer neutral. So now it's like, what's your overall charge now that you've lost electrons? Well, you're now more positive. We'll take a look at a couple examples here. So cations have the same name for the element that forms them, but their properties are a little bit different. So again, it's still sodium, it's still magnesium, it's still calcium, but they are a little bit different as far as chemical properties go. A lot of times they become more stable, and they are more likely to form reactions. So we'll take a look at sodium and calcium. Sodium we write as sodium has a charge of +1, and so we write it like this: Na+1, and that is what we would refer to as a sodium cation. However, I will say very rarely do I ever even write the 1. A lot of times I'm just going to write that single plus sign. So I'm just kind of showing you 1 for now until we get good with the numbers. And then if we look at calcium, calcium has a charge of +2. And you can see again how we write the plus signs up and above a little bit. So what this means here is that sodium must have lost 1 electron, and calcium must have lost 2 electrons because of their charges. So again, sodium has a charge of +1, meaning that it's got 1 more positive charge now. So where it was neutral before, it now is slightly more positive. And so that means it has lost 1 electron. Calcium is 2 more positive now, meaning that it has 2 more protons than it does electrons. So it has lost 2 electrons. And we'll do some more practice with that here too. Now, the way I can kind of remember cations are positive ions. Now, whether or not you got to have your mind kind of set for this, but you know, if you just think, I know a lot of you maybe aren't cat lovers out there, but pretend you are, or pretend you're somebody that does like cats. Cations are positive, so cats are positive, so you can think about them that way. Another way you can kind of think about it too is when you write the word cations, you write that T in there, right? So that T almost looks like a plus sign when you look at the word cation. So you can remember it that way too. There's lots of different ways to kind of remember. Anions. So anions are going to be negative ions or have negative charges. And another way you could remember anions is like some people remember anions kind of looks like onions with just a different vowel at the beginning. And onions make you cry, so they're negative. Okay? I don't know. Maybe that helps you. Maybe it doesn't. So again, these are atoms or groups of atoms. They can be with a negative charge. And these usually tend to be nonmetals. We haven't really discussed yet where those are on our periodic table, but they are really going to be just in the upper right corner of the periodic table. So upper and right corner, sort of where oxygen and nitrogen and fluorine and all those are in that corner there. So nonmetals are the ones that tend to form these type of ions because they end up gaining electrons. So they have a negative charge to them, not because they have minused anything. They've actually gained a negative charge. So where before they had a neutral number of, protons and electrons, because they have gained more electrons, they are now more negative and have more of a negative charge. So for anions, we usually can name them a little bit differently than we do the other ones. The other ones we usually just keep the element name with them, and then but with anions we change the last part of the name to IDE. So chloride, fluoride, oxide. So oxygen normally has 8 protons, 8 electrons. But oxygen sometimes will take on 2 extra electrons just in order to fill its outer shell, which we'll talk about later, but it leads to it being stable. And if it takes those 2 extra electrons, it's gained electrons, but it doesn't have a positive charge because it's gained. It has a negative charge because it has more negative electrons now. All right, and then chloride. This is one that we see and use a lot. Chloride or chlorine, which it is on the periodic table, becomes chloride when you're talking about it in an anion form. And again, very often we'll probably just write a chlorine or a chloride anion with just a single minus symbol. Like I said, I don't often use the one there. And another thing you may see me do, because it's just me, sometimes I write these backwards. So sometimes I'll write them as 2 minus, especially if I have a number in front of that. Like I said, I don't usually write the 1, so I never worry about it with that. But for some reason, my mind just goes there sometimes, like I'll do a 3 plus or a 2 plus instead of plus 2 plus 3, whatever. It just is, don't worry about it. And you can do the same thing too. There's no right or wrong way to do that. I kind of flip-flop. So here's another way you can kind of remember the difference between the two. This is to remember that gaining electrons gives you a negative charge. Losing electrons gives you a positive charge. Even though gain we think positive and lose we think negative, we got to get around that here when we're trying to talk about this. So losing electrons is positive. So it's kind of like dieting, all right? So if you lose weight, right, that's a positive thing. So when we lose electrons, we become more positive. Cations are formed. And then when you gain, weight and when you're trying to diet, that's a negative, right? So when you gain electrons, you are gaining more a negative amount, a negative charge. So that's when you get your anions. All right, so now let's work on an abbreviation chart. And so this kind of looks familiar to us. It may look like like from the periodic table, like the little boxes that we have. This is not the same thing though, not quite. It's kind of similar to it. The numbers on here all, a lot of them have something to do with the periodic table, and we kind of see this in our periodic table too, but it's a little bit different in the fact that we use the rounded mass number at the bottom, or not the mass number, sorry, we don't have the mass number on these ones here. So let's take a look at what all these different numbers mean, because we know what the middle number, or the middle thing here is, right? The symbol. And then what do these numbers here in the corner mean? Do they have to be in those specific spots? And the answers are yes. So let's take a look at that. So the mass number here is going to go up in the corner, the top corner. Now this is a little bit different, because before we put the mass number, we saw the mass number, the average atomic mass, and then we rounded it, was always at the bottom. So when we write them as abbreviations like this, a lot of times the mass number will go up here in the corner. So this is the total mass of beryllium, the rounded version of it, right? So if I don't have my periodic table in front of me, but whatever beryllium is, 9 would be the rounded mass for beryllium, rounded mass, okay? Number 4 goes down here in the bottom corner, and that is the atomic number. And again, that is a little bit switched from what we're used to. Usually we are used to seeing the 4 up here in the top or the corner. And depending on what you what you see or what you use, this even might switch. The key thing here, though, is the 2 numbers are usually located always on the left side. Sometimes, though, I know I've come across this. You may see the mass number here on the bottom and the atomic number here on top. Just remember, if you come across that, the number that's bigger is always the mass number, because that includes the number of protons and neutrons. This 4 here, that's your atomic number. That's your proton number, so that's always going to be smaller, because you have to add in neutrons to get your mass number. So even if they may be switched. If the number up here is smaller, that's going to be the atomic number. This will be the mass number. But usually, like I said, I always see them written on the left side, but I have seen them flipped before. And then so over here on the right side, you'll see a charge. It'll either be a positive or a negative, and then a number. And so this is the charge here in this case. So what this tells me is that this beryllium ion here has a charge of +2. So what does that mean? Does it mean it has added 2 electrons? Remember, the charges only affect electrons. They don't affect neutrons. They don't affect protons. No, it does not mean that they have added 2 electrons. It means that they have lost. Remember, if you were gaining, if you have a positive, you have actually gained or lost electrons, not gained electrons. So normally it would have, how many electrons would it have normally? That's what we want to figure out. And we use this number right here. Okay? So the atomic number, remember we just filled out those charts last time. The atomic number is your proton number, which is the same as your electron number. So normally beryllium has 4 protons and 4 protons and 4 electrons. But when I see a charge up here of +2, that means that it has lost 2 electrons. So it now is twice as positive, all right? So let's take a look at this one. Same idea here. So we have mass number, atomic number, and the charge. So this is lithium, though, and we can see that the mass number is different because of where it is on the periodic table. My atomic number is 1 less, so this should normally have 3 protons and also 3 electrons. So normally lithium has 3 protons, 3 electrons when it's in its neutral state, but a charge of +1 means that I have now 3 protons, 2 electrons. 3 protons, 3 positives, 2 electrons, 2 negatives. So my total overall charge now is a +1. All right. So when we look at a table like this, kind of similar to the one that we had before, everything is pretty much the same. The only thing that is changed now is this abbreviation that we have to work with over here. So for this here, I'm looking at sulfur, right? And if I look on my periodic table, I can see that the atomic number for sulfur is 16. That's its box number, right? And if I look at the mass number, it rounds up to 32. All right, and I'm just using mass numbers, whole rounded numbers. My number of protons, that will never change. If it does, I have a different element, so that has to stay 16. All right. Now, this -2 up here tells me that my electrons are going to be different. Normally, we would fill this in with a 16, but because it has a -2 charge doesn't mean that I've lost 2. It means that I have 2 extra negative charges now. So now this should be 18 electrons. Okay, so then the number that gets filled in up on the top here should be your mass number, which will be 32. So these numbers too on the outside, 32 and 16, these won't change unless we're talking about isotopes. If we're talking about ions, these things stay, with the numbers here. 16 has to be 16. That's your atomic number. And like I said, we might see the mass number change up here when we start talking about isotopes, but for these ones, we're just talking about charges. So for the next one, I have an atomic number of 7. That will identify that as nitrogen. Okay, and I can put my 7 down here for, oops, sorry, I'm going to come back to that one, I guess. So what is my mass number? So I'll go ahead and look that up on my periodic table. So that rounds to 14. My number of protons also has to be 7. Okay. Now my number of neutrons is still the same. My mass number, 14, minus 7, which is also 7. Now normally before we said 7 protons, 7 electrons. But I see here that I have 10. Okay, so that 10 means that I have gained electrons, but don't think positive, okay? You have more electrons now, specifically 3 more. So what does that do to your charge? All right, well, if you look over here, we'll go back to our N and put our abbreviations in there. The 14 is the mass number, so I'm going to put that on top. The 7 is the atomic number. I put that on the bottom. And then my charge now. So just like up here with the sulfur gained electrons. Normally it should have 16. So the nitrogen has also gained electrons, meaning it has more negative charges now. So this nitrogen here is going to have a charge of -3. All right, so let's look at our next one here. We have 17. 17 is the atomic number. That's going to identify this as chlorine. And my number of protons, also 17. My number of neutrons, I'm going to take 35 minus 17, and I get 18. Okay. And then my electron number here tells me that it's 18. All right, so that means that normally I would have 17 electrons because I had 17 protons. That tells me again that I have gained a negative charge, but just like gaining is negative, we're going to put a charge over here of -1. So 35 for our mass number, 17 for our atomic number, and then a charge of -1, or you can just put minus, is fine. So far all of these have gained electrons, therefore have negative charges. But let's take a look at the last one. So we're starting out with calcium. Calcium on your periodic table has a rounded mass number of 40, and then an atomic number of 20. So we have to fill in the atomic number down here. So this will also be a 20. Sorry, I'm going this way first, I guess. So the atomic number here is 20, mass number 40. That means I also have 20 protons. 40 minus 20 is also 20. Now, my electron number, normally I would have 20. But I can see here that I have a charge of +2. Get it out of your head that you're going to add 2. +2 means now you have 2 more protons and 2 more positive charges. So this will also be 18. Now, what do we fill in down here in the last little corner? Whoops, sorry, that didn't come up. This should also be a 20 down here. Maybe it's filled in your notes, but this should also be a 20 right here where my mouse is right into the 40. Oh, there it comes. Okay, so that's it for today. You do not have to begin worksheet number 3. We'll kind of go over that in class the next day that you are back. All right, thank you.